All right, I've had a request to do problem number 27 in chapter 10. A particle of mass little m moving at speed little v, 4/5 c, collides with an identical particle that is at rest. The two particles react to produce a new particle of mass capital M and nothing else. A, what is the speed capital V of the composite particle? B, what is its mass capital M? All right, so once again, we're going to use a combination of the energy principle and momentum principle to go after a particle physics situation. All right, a couple things we want to list out first. So first of all, this is a closed system. We have no information to lead us in any other direction. We can assume we're dealing with elastic collision. So basically, the kinetic energy is staying the same. Momentum is conserved. And energy conserved. And so we've got a particle, actually two of them, with mass m, and one of them has velocity 4/5 c, and m plus m. And then we have an end result of, at the end of the collision, we have a particle with mass m and speed v. Okay, so starting with the momentum principle, or with some momentum principle, momentum equations. So the momentum of the particle of little mass is equal to gamma mv. The energy of the particle of little mass that's moving is equal to E rest plus K is equal to gamma mc squared. And the end result, EM, is equal to E rest m plus K is equal to gamma mc squared. PM, capital M, is equal to gamma mv. So when you have a problem like this, just start writing out a few things that you know. So you know momentum, you know energy, you've got equations for this. This is always the right starting point. This is why I always encourage, when in doubt, start writing equations down. Because we can use these. Also, we know gamma is equal to 1 over 1 minus v over c quantity squared. Okay. So there's our energy equations, our momentum equations. Now we can write some energy equations down. So we know that the energy initial is equal to the energy final. And so we would have E1 initial plus E2 initial is equal to energy final. Gamma I mc squared plus mc squared is equal to gamma final mc squared. Gamma initial m plus m is equal to gamma final m. So all I'm doing is I'm just fleshing things out. And then we see, so here we had canceled out all of our c squareds. Now we can factor out that m times gamma initial plus 1 is equal to gamma final m. Okay, so now all I've done is write out momentum equations, write out some energy principle equations, and write out the energy principle itself. Now we can go after part A. And so we're going to take advantage of these relationships we've already derived. So we want to go after, we need momentum principle and energy principle. And these are going to give us the equations and let us solve for the unknowns. So Momentum initial is equal to momentum final. Gamma I mv is equal to gamma F mv. All things we have previously written out. That's why it's good to take the time to do that. All right, so using gamma final m is equal to m gamma I plus 1 that we got using the energy principle. Then we can say gamma I V is equal to gamma plus 1 V. So what we've done here is we can see that this is going to bring a little m onto both sides of the equation. So I've basically skipped an algebraic step and just said, okay, the m is going to cancel out. I'm going to go ahead and bring it out now. Okay, so V is equal to gamma I V, gamma I plus gamma IV over gamma I plus 1. And so what you're playing, these games that you play with algebra is you want to get something that's in as few unknown terms as possible. All right, so V is equal to 1 over 1 plus 1 over gamma times V. And then aside, we know V is equal to 4/5 C, which implies gamma I is equal to 1 over 1 minus 4/5 squared, and this is equal to 5/3. Okay, so we can just, plug that right in. Therefore, V is equal to little v over 1 plus, since we have a 1 over gamma, we can just flip that. 3/5 is equal to 5/8 times little v. And we know little v, therefore v is equal to 5/8 times 4/5 C, what we know little v is, which is equal to 0.5 C. So half the speed of light. All right, there ends part A. Let's do part B. All right, so now we're looking at after collision. Gamma final is 1 over the square root of 1 minus 0.5 quantity squared, which is equal to 1.15. Then you would have gamma initial, mv, is equal to gamma final. mv, solve for m. m is equal to gamma initial, mv, over gamma final v. Now we know what gamma final is. We have an expression for v. We know this, and we know this. All right, so m is equal to 5/3 gamma initial times little m times 4/5 c divided by 1.15 gamma final, 0.5 c, and you're given that m is 2.3 times our initial starting mass. And there you go. Problem 27.